Alright, I think we're ready to start. Alright, so welcome back to our off-season programming training. This is now week 2. So as you may have figured out from last time, when you started to control it with one joystick, we're going to be actually programming the tank drive to drive like a robot should. So first we're going to look at some different types of tank drive. Yep, we can move past that. So some different drivetrain types. So this one's called tank drive, and this is a quick picture of the exact same robot. Key thing about tank drive is that you have a set of wheels on each side. They don't turn, they don't move, they just drive, and that's how it drives forward, back, and turns. It's all just by controlling the speeds of the two sides. The next one is called swerve drive. You may have seen that robot over there. You've seen our competition robot. So using swerve drive, each wheel changes direction independently. There's a lot more motors involved. It's generally more complex, and you're probably not going to get it up and running in one night unless you already have some experience with it. So hence why we're not doing that. This is a lot simpler to start with. And then there's also another type. There are more than this, but this is just another one that is good to be familiar with, called Mecanum. And what this one does is it works kind of like tank, but also kind of like swerve, where the wheels don't turn, but because of the shape of the wheels, if you drive them in opposite directions, the front and back, you can actually make it go side to side without turning the wheels. So those are some of the basic drivetrain types. And now let's look at how we can actually control the tank drive. So the most basic way, and the way that you're going to start with, is just standard tank drive. So that means controlling each side individually. So as you were doing last time, controlling one side with one joystick, one side with the other, as it would look like this with the y-axis, all it does is it make one side go one speed, one side go the other, so you can control it however you need to, but it's pretty simple. The next one is called arcade drive. There's also one called curve drive, which is kind of similar but a little more complex that we're not going to do today. But arcade drive is a little bit more advanced, and it typically makes it more maneuverable on the field, so you can control it when you're driving faster. So rather than controlling each side individually, what it does is it has one axis, like the one on the left, for forward and backward. So you push it forward, both sides drive forward, push it back, both sides drive backward. Then the side axis right here, if you are going forward and you turn, with that, it will just turn the robot in that direction. So it's a little bit simpler because you can just go forward, turn, or turn the other way. Same thing with backwards. So it gives you a little more control. So now we're going to look at an example. Overall, the code's not going to be too crazy today because it's just building on what you've already done. Most of it's actually writing new code to refactor the existing code base to move things around. So first, you're going to be creating something called a subsystem. So I mentioned subsystems before, but basically a subsystem is how we control a certain mechanism of the robot. So today we're going to be writing a drive subsystem. You don't have to create this right now, but you're going to be making a subsystems folder inside of your robot project with a drive.java file in it. Here is a general overview of what that file is going to look like. So up here is a good place to import things right at the top. Then notice how we say extends subsystem base. So we get certain features, certain default methods, things like that give us some important capabilities, and we get that from subsystem base. Then inside of here, kind of like in robot.java, you're going to put your motors, right? So before you made a motor, gave it a name, and then you would declare it inside of the constructor in robot.java. It's the same thing in here, except this time we're going to have 4 motors instead of 1, because each side on the robot has 2 motors. Then in our constructor method right here, we're going to create each one of those motors, give it each an ID, which I'll write up on the board later. And then we're going to do some important things like inverting one of the motors, because one side will drive the opposite direction of the other unless you invert it. And then also creating something called leaders or followers, because with 2 motors on each side, it's easier to control just one each time than controlling two. So we have one of them be a follower that does the same thing as the leader. So one of the ones on this side would be the leader, the other one would be the follower. Then what we do is we make a command. Okay, so you may or may not have heard of a command before, but a command is basically the same thing as an action that the robot can take. We don't just call methods or functions in our code to do things, we actually use commands because we have a more advanced way of doing logic to decide what thing to run when we do that. I'll get into the drive command in a little bit, but just know that's how we drive the actual robot, is by running a drive command. Then we have 3 different drive controls. We're going to skip this one for today. Drive percent, same thing as drive tank, gives a left speed and a right speed. This is going to be pretty simple, just sets the 2 motors. Drive arcade, we'll get into the math there. Stop, all that's going to do is stop each motor. So you can use the stop motor method like what we tried last time. So now let's actually look at some of the specific code. So in drive, this is the same thing you should have already seen from our robot.java, right? Except we have 4 motors now. Notice we have left leader motor, left follower, and then right leader motor, right follower. So now that we've made our motors, right, we actually have to initialize them. These are the IDs that we're going to be working with. 1 is the leader on the right side, 4 is the leader on the other side, on the left side. Then what we have to do here is we can use this set inverted method to invert one of the sides. In this case, we're inverting the right leader motor. So that'll invert the right side of the robot so it drives the opposite direction, which actually makes it drive straight. Because if you drove both of them forward, the robot would actually turn in place, which we don't want. Then we also have to make the follower motors follow the leaders. And we want them to go the same direction so we don't invert them. That's why it's false there. So after we've made the motors, what we can do is actually work on our first command. So with the drive command, this is what the command looks like. There's a lot going on here, and a lot of commands have even more going on than this. But I'll try to make this as simple as possible. So a double supplier. Well, double's in the name, so it does something with a double. And what it does is it supplies a double. So we can call this getAsDouble method, and it will get us a double, which is going to be the left axis or the right axis output. Then notice this drive tank method, same thing as drive percent that we looked at before, and it just takes in those 2 doubles. Now finally we have this run method and this strange parenthesis arrow thing. So that's called a lambda function. Not really important that you know what that is, but basically it's telling it to run this code. Run means run this code over and over again. So it'll run it every 20 milliseconds, basically, is what this command is doing. That's what that run keyword does. So now this is how we actually drive the tank. Notice last time we used set. Here we're using something a little bit different. You could use set and it would work just as fine. But here we're using set voltage. So our robot typically works off of around 12 volts. So what this does is it helps to make the driving a little bit more consistent, because rather than using set, which always uses the maximum voltage of the battery, right, which could be 12.7, could be 11.5, it'll always try to use at maximum 12 volts and scale from there. So that helps us be a little bit more consistent. But again, you could just put set here and put left speed in there and right speed instead. And also we're just using the leader motors here. No need to control the followers because they already follow by default. Then with arcade drive, it's a little bit more complicated, but not really. I mean, this is not very hard math to do. But first, let's actually understand what these 2 mean, X speed and Z rotation. So it's conventional with these robots that on a field, you might think of a position of the robot as like an XY point, right, on a graph, which is pretty common. But when you're thinking in terms of the robot itself, it's a little bit different, okay? So the robot has an x-axis, and the x-axis points forward. So this is the front of the robot with the camera on it. That's forward. The y-axis is actually to the left. it's positive to the left, and the z-axis is up, which should make sense. So then if we look at this graphic right here, we see roll, pitch, and yaw. This being the x-axis, this the y, and that the z going down or up. It doesn't really matter. But z rotation simply refers to the yaw, where rotating around the z-axis, which goes up, means turning like this, which is how we want to turn the robot. We don't want to turn it like this or like this while we're driving, typically just like this. So that's why we call it z rotation, x speed for going forward and backward. And all we do to do these calculations is we set our left speed is our x speed minus the z rotation. So if you drove it all the way forward, it would just be 1 for the x speed and 0 for the z rotation. What it's saying is if we want to turn a little bit, like 0.1, it will subtract that from this one and add it to this one, right? So it'll make this one go faster, this one go slower, or vice versa if you go the other way. And that should be pretty simple. Then that is pretty much it for the drive.java file. Overall, all we did was make our motors, make some methods to control the drivetrain, and then actually make a command or an action that actually runs that method. Then in our robot container, here's where we put our joystick logic. Again, we put all this in the robot.java file last time. We're moving it to robot container because this is normally where it belongs. So we have our two joysticks, our left joystick and our right joystick. We have a private drive, which is our drive subsystem called drive, and then we actually make a new instance of it right here in our robot container. Okay? Then we call a method called configure bindings. Some of you may have seen it before, some not, but configure bindings is like a one-stop shop in the entire robot for where we put our different actions, like our commands that are running on the robot. So something like, for example, run or drive until sensor activated. Maybe that's something we're trying to do. That could be the name of a command. And maybe that's something we want to call when we press a button. We want to run that. So pretty much all of those go in one place in this one method. So if you ever need to understand why is something happening when I press this button, it's always just in one place. It's an easy place to look for. Then our default commands go there, and that's what we're going to look at for our drivetrain. So when we configure our binding for the drivetrain, right, we don't want to press a button to drive. You expect to enable the robot and just drive. So this is why this is going to be called something called a default command. Now we're going to talk more about that next week, what all this stuff with commands is. But for now, all you have to really understand is that each subsystem has commands that are running, right? So you could press a button to run a certain command, and then press a different button, run a different command. And each subsystem really only has one at a time, because imagine if you try to do two different things with the drivetrain at the same time, right? How do you drive forward and drive backward at the same time? That doesn't make sense. So you can only really do one of those at the same time, so you can run one command per subsystem at once. And when those aren't running, if you have a default command, that will run. So since we don't have any other commands to run with our drivetrain, it'll pretty much always run our drive command. That's why it's a default command. It runs unless we're doing something else with the drivetrain. And then here we have this syntax, this colon get left axis. We'll look at what these methods are in a little bit, but these are methods of our robot container. And this is a shortcut for passing them in as, if you remember from the method, it's a double supplier that we're passing in. This is a shortcut for passing that in, rather than having to make one of those lambda functions that I showed you earlier. This is a little bit simpler. So now let's look at how we actually get the controls from our axes. So last time all you would have done is myJoystick.getY or getX. Some of you may have noticed though that when you let go, sometimes the robot would still drive just a little bit, right? Just a little bit, but it would. And what's happening there is our joysticks, they're not perfect. So if you let go, sometimes it could output 0.1 or 0.01, some really little number. But that little number can still make the robot drive. So we have something called deadband that I'll get to in a second. But you can see your joystick.getY or getX, and then we give it a tolerance as well. Basically, the way this deadband method works is it looks at the input we get from the joystick. If that input is less than our tolerance, we say the driver's not actually trying to drive the robot. It's just a fluke. It's one of those little sensor errors, so we just return 0, right? So if your hands are off the controller, you expect it to stop, and it will stop in this case. Otherwise, what we do is you could just return value here. That would be totally fine, right? That value meaning whatever your joystick value is, like -1, 1, 0.5, whatever. You could just return that. This is a little more complicated, but what this does is it scales it down. Okay, so with our tolerance being 0.5 or 0.05, what happens is when you go above 0.05, suddenly you start driving at, for example, 6% from 0. What if our tolerance were 0.1? Suddenly we start driving at 10% speed right after we were completely stopped, right? That wouldn't make sense to the driver, right? Why am I suddenly going fast when I intended to go very slowly? So with our deadband, we also want to make sure that we're scaling our values correctly. So what we do here is we actually take our value minus our tolerance. Maybe our value's 1 for example, right? And then we subtract the tolerance. So that would be 0.95. Then we divide it by 1 minus our tolerance, which is also 0.95. So in that case, we get 1. Now, if it were like 0.06, right? That's 0.1 more. Then we would do 0.06 minus 0.05, and we would get 0.01 divided by 0.95. So basically, it scales it down so that we don't have that sudden jump from the tolerance. You don't have to do that. You can just put value there. That'll work fine too. That's it. So we're going to look at the lab, okay? So if you could go there, because there's a good amount to talk about here with these labs. So most of today is going to be labs, as you may have already discovered, because there's more. You don't even have to complete all of this, but first what we want you to do is make the drive subsystem, basic tank drive, don't start coding yet, and arcade drive, right? So that's going to involve the 4 motors, the 2 joysticks, all of that. That's already on the presentation when you scan the QR code. Then there's 2 optional ones that you can do in either order, and you don't have to complete them, right? We definitely want you to get the first 2. These 2 are okay if you don't complete them or if you just don't succeed at all with them. It's okay. I've included the documentation here, which should give a little bit of reference if you need to figure something out. Or you can definitely ask me questions, on-sheet questions about how to do this, because it's going to be more complicated. But basically, the first one that's optional is pressing a button to switch between tank drive mode and arcade drive mode. Right? So you could press it once to switch to arcade drive, switch it again, switch back to tank drive, and just keep doing that. You may want to consider making a variable in your drive subsystem, maybe a Boolean, that will switch which method it's calling in the command. Alternatively, you can make it so that you can press a button to quick turn. So you can press a button and it will quickly turn like 180 degrees or 90 degrees. Sometimes you need to do that during a match. You need to suddenly turn. So that would be making a different command, right? And again, that's not something neither of these we really went over how to do them. They're more challenges if you feel like taking those on and learning a little bit on your own. So yeah, I'm going to put a battery in and get this set up. Ignore the camera there, and you can start writing code, and feel free to ask questions because I expect you to have plenty.